Hi, welcome to Sreedhar Academy. I am k.r.sreedhar. I am here to start a new lecture series on manufacturing technology subject under mechanical engineering branch. Today we are going to discuss about properties of engineering materials. To receive latest updates on my lecture series, do subscribe to my YouTube channel Sreedhar Academy. What is engineering materials? The substances which are useful in the field of engineering are called as engineering materials. The materials which we possess are obtained from the ore or from the nature in the raw forms. In our daily life, all the objects we use are composed of number of materials. Materials and processing methods are necessary for enhancement of our national quality of life. In generally, there are some requirements for the engineering materials. The engineering material requirements are fall under three categories. They are fabrication requirements, service requirements, and economic requirements. What is fabrication requirements? Fabrication requirement means that the material should be able to get easily shaped. For example, the material should be castability, forgeability, formability, machinability, and it should be sintered and joined easily. Those are the fabrication requirements. Coming to the service requirements, it implies that the material selected for the purpose must stand up to the service demands. For example, it should have a proper strength, it should have proper wear resistance, proper corrosion resistance as per the service requirements of the end product. And economic requirements. It is the demand that the engineering part should be made with the minimum overall cost. That means minimum overall cost may be achieved by proper selection of the both technical and marketing variables. Next, here a material is selected based upon the following considerations. How these engineering materials are going to be selected means by following these considerations. First of all, based upon the properties of material. Which properties means based upon the mechanical properties like strength, ductility, toughness, hardness, strength to weight ratio, etc. These are all the mechanical properties of the engineering materials, and also based upon the physical properties of the materials. For example, density, specific heat, thermal expansion, thermal conductivity, melting point, etc. like that. And based upon chemical properties of the material. For example, oxidation, corrosion, flammability, toxicity. These are all the chemical properties of the material which we need to consider before selecting of the engineering materials. And next, what are the manufacturing properties of the materials? That means, as I said earlier, formability, castability, machinability, weldability, joinability, and forgeability. These are all the different manufacturing properties of the materials which should be considered before selecting of an engineering materials for our further manufacturing process. Next, cost of the material. That means the raw material which we are going to procure from the other vendors should be affordable in nature. Then only we can maintain a balance of production cost throughout the production of the component in order to release that component within the best quality and within the reasonable price to the end users. Next, availability of the material. Here, the material which we are going to procure from the other vendors should be available in the desired shape and desired size. And also, there should be a proper there should be a proper supply of the raw material from the vendors. Then only we can produce these components by using of that raw material without having any lag. Next, service in life of materials. That means there should be a strong dimensional stability of the material by maintaining wear and corrosion resistance. Next, appearance of the material. The material which we are going to procure should be in good color and having surface textures as per the requirement of the production. Now we are going to see about the mechanical properties of engineering materials. First of all, what does it mean mechanical properties? That means the characteristic of a material which describes its behavior by the action of the external loads are referred as a mechanical properties. Some of the examples for the mechanical properties are strength, stiffness, toughness, hardness, elasticity, plasticity, ductility, malleability, brittleness, creep, resilience, fatigue, etc. And again, its strength is also subdivided into the different types. That means compressive strength, tensile strength, and shear strength. Along with the mechanical properties of engineering materials, while producing a product, we need to understand some technical properties of the engineering materials also. What are the technical properties of engineering materials means? I would like to say some examples. The machinability of a material, castability of a material, weldability of a material, and durability of a material. These are all the technical properties of the engineering materials which will help us a greater in action while producing a product. As we discussed earlier about the different mechanical properties of engineering materials, let us see in detail about each and every example. First of all, strength. Strength, it is defined as the ability of the material to resist the loads without failure. That means it is usually expressed or measured in terms of maximum load per unit area. And again, this further strength is divided into the three types. Those are tensile strength, compressive strength, and shear strength. First, tensile strength means tensile strength is defined as the ability of the material to resist the stretching without fracture. Next, compressive strength. That means it is the ability of the material to resist the compressive, that means squeezing loads without fracture is known as the compressive strength. Next, shear strength. It is the ability of the material to resist the transfer loads. Then the material is known as shear strength. Next one is stiffness. It is the ability of the material to resist the deformation under the action of external loads within their elastic limit. This stiffness is going to be measured by using of modulus of elasticity. Next, toughness. It is defined as the maximum amount of energy that can be absorbed by the body without fracture during its plastic deformation stage. This toughness of a metal offers the resistance to breaking when the force is applied. Next one is hardness. It is defined as the ability of the material to resist the scratching or indentation or penetration by the another hard body. This hardness is directly related to its strength. Next one is elasticity. It is the ability of the material to deform under the action of external loads and return to its original shape when the external load is removed is known as elasticity. Next, plasticity. It is the ability of the material to deform under the action of external loads and return to its new shape when the external load is removed from it is known as plasticity. Next one is ductility. It is the ability of the material to be deformed plastically without rupture under the action of tensile loads. Due to this specific property, the material can be drawn into the form of fine wires without fracture. Next, malleability. It is the ability of the material to be deformed plastically without rupture under the action of compressive loads. Due to this specific property, the metals are going to be hammered and rolled into the form of thin sheets as per the requirements. Next one is brittleness. By the action of external loads, these materials are going to be sudden fracture without giving any visible permanent deformation. Next one is creep. The slow and progressive deformation of a material within the time at the constant stress is known as creep. Next one is fatigue. Due to the action of external loads, the failure of a material will be obtained under the repeated stresses is called as fatigue. Next one is resilience. Resilience is the ability of the material to absorb energy when it is deformed elastically and release that energy upon unloading of the external loads. Proof resilience is defined as the maximum energy that can be absorbed upon the elastic limit without creating any permanent distortions. This modulus of resilience is defined as the maximum energy that can be absorbed per unit volume without creating a permanent distortion. Now, I would like to explain some technological properties of engineering materials. First of all, machinability. It is a cold working process of the material to remove the unwanted material from the workpiece by the action of some cutting tools. So, softer materials can be machined easily than compared to the harder workpieces. This machinability depends upon the chemical composition, structure, and its mechanical properties. Next one is weldability. It is the ability of the material to be joined by the process of welding. This weldability depends upon the chemical composition, physical properties, and the heat treatment which they are going to be subjected. Next one is castability. Castability is refers to the ease with which it can be readily casted into the different shapes and sizes, and it is concerned with the behavior of the metal when it is in molten state. Next one is strain hardening. The strengthening effect produced in the metals by plastic deformation, which is nothing but a cold working process, is called the strain hardening. The strain hardening reduces its ductility and corrosion resistance, but it raises its hardness and electrical resistance of a material. Next one is durability. It is the ability of a physical product to remain its functionality without requiring any excessive maintenance or repair when it is faced with the challenges of normal operations over its design of lifetime. I hope you all understand our today's lecture on properties of engineering materials. Thank you for watching my video lecture. If you like my video, please like and share it. And don't forget to subscribe my YouTube channel Sreedhar Academy. Thank you.